Hi everybody, welcome to another video in course Algebra, section 6.3, matrix operations and their applications. First, what is a matrix? A matrix is a two-dimensional array of numbers, so pretty much a table. We have rows and we have columns. And then not necessarily of numbers, it could be expression or symbol or anything, but we'll have a table that have rows and then columns. These items are arranged in rows and columns. If the matrix A above has m rows and n columns, if m equal to n, then A is a square matrix. Alright, so the reason we know that A is m rows and n columns, because if we look at the first digit or the first number would indicate the row. So everything here on first row we have the first number of 1. The second number will denote the column. So everything on this column we have 1 because that's on the first column, and then this is on the second column, so that's 2. So the first number denote the row, the second number denote the column. When we have, let's say, something like this, and then we don't know if that is on the first row 23rd column or 12th row 3rd column. So in that case, either we write a comma to denote that. To denote which one we're talking about, but the first number denote the row and the second denote the column. Right. So when we write Aij here, we say this is on the I row and J column. Right. Two matrices are equal to each other if they have the same order and the corresponding elements are equal. Right. And the order, I forgot to highlight that. The order of the matrix, we write order m by n, meaning if I have m rows and n columns, then we say the order of m by n. So the number of rows, and then this is not time, but we say it's not multiplied, so m by n, so m rows, n columns. The first one is the number of rows, the second one is the number of columns. That gives us the order of a matrix, and they're equal if they have the same order or same dimension and the corresponding elements are equal. Alright, next, matrix operations. First one is addition and subtraction. When we add two matrices, they have to have the same order, meaning they have the same rows and the same number of columns. So in that case, we can just add or subtract the corresponding elements or entry. And element and entry, each one occupy each cell of the table on the matrix. Right. So find A plus B, so A plus B. One, 2, -3, 4, -1 and 0. Add 0, -2 and 3, 4, 2 and 1. Now we add them together, meaning they have the same order. Both of them have 2 rows, 3 columns, so 2 by 3, 2 by 3. So the same order, check. And when we add or subtract, just add or subtract the corresponding entry. So 1 plus 0, 2 plus negative 2, negative 3 plus 3. By the way, we do not write a comma in between the entry of the matrix. We just leave a space there. So 1 plus 0, 2 plus negative 2, negative 3 plus 3, 4 plus 4, negative 1 plus 2, and 0 plus 1. So that gives us 1, 0, 0, 8, 1, and 1. Right. And subtract, still the same thing. They should have the same order or the same number of rows, the same number of columns. Now we subtract. So we just, they have the same dimension or the same order. Both of them are 2 by 3. So we just add, this time subtract the corresponding entry. So 1 minus 0, 2 minus negative 2, negative 3 minus 3, 4 minus 4, minus 1 minus 2, 0 minus 1. So we have 1, 4, negative 6, 0, negative 3, and negative 1. Right, so that's what we do. The next operation is scalar multiplication. Scalar multiplication is, by the way, the scalar is just a real number. So scalar is just a real number. So when we multiply that real number into the matrix, simply we just multiply that into every entry of A. So multiply that number into every entry of A. So that will be easy. So let's look at this example. Matrix A is that, matrix B is that. Now find negative 5 times B, negative 5 times the matrix B. Matrix B, 2, negative 3, 5, and negative 6. So we'll multiply it out. Negative 10. I just not skip that step. So we will take that scalar, that number, multiply to every entry of the matrix. So we have negative 10, 15, negative 25, and 30. Right. Next, we have 2 times matrix A plus 3 times matrix B. So this is just order operation, multiply, divide, before add or subtract. In this case, we do not have division in matrix, so just multiply. Actually, this is multiplied by the scalar, so multiply first and then add or subtract. So 2 times matrix A plus 3 times matrix B, 2 times the matrix A of negative 1, 4, 3, and 0, plus 3 times matrix B, So we multiply the numbers in first. 2 times -1, 2 times 4, 2 times 3, 2 times 0, and then plus. Now we multiply 3 inside. 3 times 2, 3 times -3, 3 times 5, 3 times -6. So give us -2, 8, 6, and 0, plus 6, -9, 15, and -18. Right, and then we just add the corresponding entry. Again, I will not skip that step. I just say -2 plus 6, 8 plus -9, 6 plus 15, 0 plus -18. So we have 4, -1, 21, and -18. Right, so that's what we have. Don't worry, we will use the calculator to do this later too, so we can check our answer. Now, so for x, if a plus 2x equal to b. So now this we do just like the equation. We will subtract a on both sides. So we have 2x equal to b minus a, and of course b and a being those matrices, and then divide by 2. So remember, we don't really have division here. What we do instead is multiply by 1/2 on both sides. So give us x equal to 1/2 b minus a. So that's equal to 1/2 the matrix B, 2, -3, 5, and -6. Subtract a, -1, 4, 3, 0. So we have 1/2. Subtract the corresponding entry. 2 minus -1, -3 minus 4, 5 minus 3, and minus 6 minus 0. So that gives us 3 minus 7, 2, and a minus 6. And multiply 1/2. Sorry. So that's what we have. And then multiply 1/2. So we just multiply 1/2 to everything. So I'm just going to run out of space, so I just skip that step. So 3/2, -7/2. 1/2 that's 1. 1/2 times that's -3. Right. So that's what we have. So far we have add or subtract and a scalar multiplication. So we multiply that scalar to every entry of the matrix. Next we have matrix multiplication, meaning we multiply matrices together. Whatever you do, do not multiply corresponding entries because we might not have the correspondence. If A is an m by n matrix and B is an n by p matrix, then A times B is an m by p matrix. Right. So when we multiply the matrix, like I said, they may not have the correspondence, But what we have to have is the middle numbers have to match when we multiply the matrix. So in that case, the outside number will give us the dimension of the product. In particular, when we multiply two matrices together, a particular entry will be the sum of the product of row A and J column of B. So the row from the first column, row from the first matrix and column from the second matrix. Row from the first matrix, column from the second matrix, the middle number must match. So those are the things that we need to watch out for. Right. Let's look at an example here. First, A times B. So I'm going to write out A times B. The matrix A. Times the matrix B. Right, now just multiply. So let's check the dimension. Okay, this one, there is 2 rows, 1, 2, 3 column. This matrix, 1, 2, 3 rows and 1, 2 column. So the middle number matches 3. Middle numbers match 3 and 3. So the outside is 2 and 2. So the product is going to be the outside number 2 and 2. So when we multiply this together, we will have a 2 by 2 matrix. Right, the middle number match the outside number, give us the dimension of the product, so we know it's going to be 2 by 2. So how do we get the 2 by 2? So for each one, let's say if we want this element, this entry, regardless of the matrix we have, this is on the first row and first column, right? So this is on the first row and the first column of this matrix. The rows come from the first matrix, the column come from the second. So this is on the first row, first column. So first row and first column, right? So both of them have 3 in them. So 2 times 1, negative 1 times 0, 3 times negative 2. So because the rule says it is the products of the row from the first matrix and the column from the second matrix and the sum of the products, meaning we will multiply those entries and then we add them. So to get this, we're going to have 2 times 1 plus negative 1 times 0 plus 3 times negative 2. So 1 times 0 is 0. So 2 minus 6, 2 minus 6 is minus 4. Next, if we want this entry, this is on the first row, second column. So we use first row, second column. So 2 times 4 plus negative 1 times 3 plus 3 times 1 give us this entry here. So 2 times 4 is 8 minus 3 plus 3, so it's just 8. Next, we go here. So this is on the second row, first column. So we use second row and first column. So 0 times 1 plus 2 times 0 plus 1 times -2. So that's 0, 0, and -2. Like that. And finally, this on the second row, second column. So we have second row, second column. So 0 times 4, 2 times 3, and 1 times 1. So 6 and 1, that's 7. Right, so just like that. Right, now let's find b times a. B times a. B is 1, 4, 0, 3, -2, and 1. Times a. 2, -1, 3, 0, 2, and 1. Right, so this is 3 rows and 2 columns. 2 rows and 3 columns. So the middle numbers match. The outside number 3 and 3 will be the dimension of the product. So the product here is going to be 3 by 3. Right, so we have 3 by 3. Now I don't have all the 9 different colors, so let's just look at some of them. Let's look at this one. First row, first column, right? First row, first column. 1 times 2 is 2 plus 4 times 0. 2. And then let's say if we want to pick this one. This on the second row and third column. Second row and third column. So times 3 plus 3 times 1. That's 0 and that's 3. Right. Of course, with that we can do the rest of the matrix. For example, if we're talking about this one, this is on the third row, second column. Third row, second column. -2 times -1 is 2. 2 plus 2 is 4. Right, and then we can do the rest of the matrix. This one, first row, and second column. That will help. First row, second column. 1 times -1 is -1. 4 times 2 is 8. -1 plus 8. Right, this one, first row, third column. 1 times 3 is 3. 4 times 1 is 4. Now go to the second row. First column. 0 times 2, 3 times 0. So 0, 0. 0 times -1 is 0. 3 times 2, 6. and then third row, first column, negative 2 times 2 is negative 4, because 1 times 0 is 0. And finally, negative 2 times 3, negative 6. Negative 6 plus 1, negative 5. Right. That's how we do it by hand. So we have 3 operations: add or subtract, multiply by scalar, and multiply matrices together. Right. Now let's check using calculator. So on the calculator, you see that above the x to negative 1, there's the matrix in blue. That means we have to hit that button to go to the matrix. Of course, we turn it on first. Second, matrix. Now we see there's names, math, and edit. Focus on the names and the edit. Names is where we recall the matrix, and edit is where we input the matrix. So I go to edit here. Let's look at this example. We have the matrix A, 2 rows, 3 columns. Now we just enter the number 2, negative 1. Notice this is the negative 1, and this is subtract. The negative is in front of the number, subtract is between two numbers. So we have negative 1, enter, 3, enter, 0, 2, and 1. So when we're done, and 1. When we're done, hit second mode to go back to the home screen. Yeah, I did have that. Second mode. Right, do that again. Second matrix. You see now we have the matrix A is 2 by 3, which we entered earlier. So that's good. Now go to edit. Again, now go down to B, and now we edit matrix B, which has 3 rows and 2 columns. So there's 1, 4, 0, 3, negative 2, and 1. Right. So second mode to quick, second matrix. Again, now we have A and B. Right. Now when we do the operation, let's say A times B, we just say second matrix. Under names, highlight the matrix A with enter. So that matrix A, second matrix again. Under names, go to B, and now we select B, hit enter, so we recall the matrix. So we have A times B here. That's what we have. Right. Now, if we have B times A. Right. So that's what we have. So we store the matrix first into edit, and then under names we'll record it, and we just enter on the home screen. Right. If you want to delete the numbers in the matrix, second, a plus sign, memory management, and delete. Just delete matrix. Here, hit delete, delete. Back to home screen, and you see it's not there anymore. Once again, second matrix, memory management, and delete, and go to matrix. If there's anything here, just hit delete. We don't have that any matrix here, so that's good. Right. So that's one way to enter it. Of course, we can put everything in the home screen. If you're using TI-84 and using the newer, like you hit the second the plus sign, go to about, hit enter. If you have 2.55 MP, that is the newer edition on the TI-84. If you have the color, that different operation. I don't know about that, but for TI-84, the standard one doesn't have color. 2.55 is the newer one, so we can just enter everything in in home screen. So let's try see this. We have 2 times a matrix. So hit alpha zoom. We have a 2 by 2 matrix, so 2 by 2, that's good. Right. So the difference here is that when you enter everything here, do not hit the enter key until you done. Only use the arrow. -1, 4, 3, and 0. Then +3 alpha zoom. Once again, 2 rows, 2 columns. And now we have 2, -3, 5, and -6. When we're done, hit enter, give us the answer. Right. So of course you can enter everything in the home screen, but make sure that on the home screen you do not hit enter until we're done, because if we hit enter by accident, for example, -1, we hit enter and we get out of that, the calculator understand that you done, so that no more to entry, no more value to enter. So use the arrow in here when you enter the numbers in the home screen. But if it is under edit, we don't use the arrow, use the enter. Like 1, if you want to the next cell, hit next, it's not going to work. You have to hit enter to go to the next one. So whether we enter everything in the home screen or we enter in the edit mode, different things, but the end result should be able to check our calculation nicely. And with that, I stop the video for section 6.3 here. As always, thank you for watching. See you in another video in course Algebra.